Hello everyone. I hope I am audible. So I'll wait for 2-3 more minutes and then we'll begin. So I hope I'm audible. So please anybody confirm if am I audible? Can, can anyone confirm? You can speak. Uh, Hello. All right. So I think I will proceed, uh, assuming that I'm audible. So please anybody confirm am I audible? All right. So, good evening, everyone. I am Shubham Keshri, and I am a TA for this course, Strategy and Introduction to Game Theory. And this is the first week, and we will be discussing some problems and some concepts in this class. So, I would request everyone to speak in this lecture because you will not be allowed to send some text messages in this chat. So, we will not be able to communicate via chat. So, I would request everyone to please uh, speak and ask doubts. All right. There is no issue. You can just unmute yourself and speak. All right. Okay. So the first question which I have here is about a game. So this question says that what are the characteristics of a game? So if you remember, in the first lecture uh, of the course, you were given some of the characteristics of a game. So this question has four options. The first is it has multiple players. The players try to minimize or maximize their utility. The game has some rules, or all of the above is true. So you have to select one option. So how will this problem solving session go? We have problems in this class, and I would expect you to unmute yourself and speak your answer. Speak the answer which you think is correct, and then we'll move on to discuss the concept on the of the question, and then provide the answer. All right. So this is how we'll proceed in this session. So the first question is, what are the characteristics of a game? So if you have seen professor's lecture, then you will be easily able to uh, tell what the answer of this question is. So you can just unmute yourself and reply. Anyone can speak. Yes.
All of these.
All of this, yes. So if you remember, in the first class, a game was actually described as having a competitive nature. It has multiple players. There is some utility function or some payoff which the players wants to minimize or maximize. So this is what it is, maximization of utility. And a game has some rules. All right, so these are the four characteristics of a game. Over here, three are mentioned, and we are saying all of the above is true. All right, so we'll proceed to the next. So the next question is on dominant strategy. So here are three statements, and you'll have to see which of the three statements, and the last one is none of the above. So which of the three statements uh, give a crude definition of dominant strategy. So this is not a textbook definition. These are some definitions where you can understand what a dominant strategy is. So just read, or I will read for you. The first says it yields a high payoff than any other strategy, regardless of what other players do. All right, so it says that no matter what the other players do, this strategy will give a higher payoff than any other strategy of the player, regardless of what other players do. The second definition is it yields a higher payoff only if other players follow a specific strategy. So it mentions that a player, suppose P2, is playing some specific action or strategy AI, and for this strategy, it is giving me higher payoff. The third statement is it yields a lower payoff, or none of the above. So you can just read through again. Yes, there's a, you can speak. No need to put your hands. You can just speak. Yes.
I think it's option A.
Yes.
Regardless of what other players do, a strategy has to work. Then only it's dominant.
All right. Does anybody have other things otherwise? Anyone else thinks that apart from A, anything else seems correct?
No, A is the correct answer.
Yes, A is the correct answer. So dominant strategy says that no matter what other players, which action the other players are taking, that strategy which is dominant will always yield a higher payoff than all other actions a player has. So suppose a player P1 has some strategies A1, A2, A3, AN, and another player P2. So we have two players. So we are talking about two-player game. All right. There can be multiple players. I have questions on multiple players as well. And by the way, if you have doubts in questions related to assignments, we can discuss some things related to the assignments as well. So I have questions similar to the assignments also along the way. So you can just be here and we will discuss. So we are talking about a two-player game, and the first player has strategies A1 to AN, and the other player has strategy B1, B2, BN. And can anybody tell me why I am not writing A1, A2, AN for player 2? You can just speak. It might be correct, it might not be correct. Doesn't matter.
The
Why am
strategies do differ. The
Yes.
strategies do differ.
So in the examples which we have seen in professor's lecture, the strategies of the two players were same. For example, in prisoner's dilemma, both the players have the same strategy, either to deny or confess. But here I am taking a generic example where the players can have different strategies. So the first player has strategies A1 to AN, and the second player has strategies B1 to BN. Actually, how this is uh, thought about is that player A1 has a strategy set A1, which is from the set A1, A2 till AN. This is a set, and player A2 has a strategy set B1, B2, BN. So what dominant strategy is? Suppose we say that, so we'll go to the next slide. Suppose AI star is the dominant strategy for player 1. Now, no matter what second player chooses, so I'll just say BJ, no matter what the second player chooses, this AI, the payoff the payoff which the first player will get. Sorry, this will be first player. Where is the eraser? All right, so here is the eraser. So I'm saying no matter what the sorry, just a minute. Yes, I'm saying the first player is choosing A1 star, and the other player can choose any strategy it wants. So I'm just writing BJ. This utility will always be greater than equals to the utility of the first player choosing any other strategy AI when BJ can be any BJ from the set A2. So I have written in cryptic form. If you think this is cryptic, this is what it means in plain English. So no matter what the second player chooses from B1 to Bn, that strategy, suppose it is A1, it is best over all the other strategies of player A1. All right. So this is one example of a voting game. In this game, I have taken, you will have to tell me in this game, you have to identify what are the players and the action sets. All right. So I'll just read once and then let you read again. So this is a voting game when there are three candidates, candidate 1, 2, and 3, or C1, C2, C3, and there are two voters, V1 and V2. Now, this voter can vote for either candidate 1, 2, or 3. If both voters vote for the same candidate, then that candidate wins. And if it has conflicting votes, so both have different votes, then none of them wins. All right. So just tell me for this question, what are the players for this game? And what are the action sets for this game? So first of all, how many players are there in this game?
There are, I'll just take a guess. There are two players.
Two
It is-
players. Which are the players?
It is voter 1 and voter 2.
And why not the candidates C1, C2, C3?
C1, C2, C3 actually becomes the options that they have. This is the
correct. You are correct. So over here we have two players and they have action sets. So they can either choose C1, C2, or C3. So is there anyone who has doubts in this? So what I am saying is we have two players, V1 and V2, and V1 has an action set. So action set, so I'll write like this, action set of V1 is C1, C2, C3, and action set of V2 is actually, okay, C1, C2, C3. So does anybody has any doubt in this? Why not C1, C2, C3 are the players here? All right. So in this game, there are two players. And each player has three actions or strategy. All right. Each player has three strategy. So the next question is same question. Now we have to identify the Nash equilibrium. So before identifying the Nash equilibrium, we have to know the payoffs of each player. So what I'll tell you the payoffs of the each player. So if now, yes, all right. So I'll just draw the payoff table. There is some noise coming. Could you mute? Yes, you can just unmute. Not an issue. All right. If you want to speak, you can just unmute. So we are saying that there are two players, V1 and V2. So I'll just draw the table. So this table will actually tell us what are the utilities of each player. All right. So in the meantime, you can also draw if you want, or you can just uh, solve the problem along with me. And there are three action sets: C1, C2, C3, C1, C2, C3. All right. And what these voters want is they want a candidate to win. They doesn't want the voting to be undecisive. So the payoff of the voters are that they want a candidate to win. So suppose both chooses the same candidate, then each gets a utility of 1. All right. And if two different candidates are chosen, they get a utility of 0. All right. So their preference is to obtain a candidate. So this is the payoff table. Is anybody here who has a doubt in this payoff table? So this payoff table is written as each voter wants this voting to have a decisive result. So either a candidate 1 wins, either or 2 or 3. All right. So any doubt in the payoff table or the utilities of the players? All right. So if you don't have any doubt, so please identify. Do not speak just yet. Just identify the Nash equilibrium and let everybody else also work out, and then we'll discuss. You can just unmute and speak. We'll just give 1 minute. It's not a difficult problem to solve. Yes, you can speak. Yes, yes.
1, 1 indicates that the voters have voted the candidate, that particular candidate.
Yes, so this not 1, 1. 1, 1 is the utility functions for the utility pair for the players. So this box, it signifies that voter 1 has voted for candidate 1 and voter 2 has voted for candidate 2. 1, 1 is actually signifying the utility of player 1 and utility of player 2. This is a tuple which signifies the utility of both the players. Each cell is actually signifying which voter has voted for which candidate. So if we are in this cell, voter 1 has voted for candidate 2 and voter 2 has voted for candidate 1. This is what this table means.
Okay.
All right.
Okay.
This 1, 1, 0, these are utility of player 1, 2.
So they have utilized it in the first cell. Is that means that part is not clear, sir? Sorry.
Okay, no problem, no problem. I'll just draw the payoff table again. All right. So what I'm saying is, so each player has 3 strategies. Now, if voter 1 votes for C1 and voter 2 votes for C2, so this is the cell we are in. All right. Voter 1 is voting for C1 and voter 2 is voting for C2. So this is the cell we are in. Over here, the utility of voter 1 will be 0 and utility of voter 2 will be 0 because the vote has given or the election has given an undecisive result. Similarly, when voter 1 votes for candidate 1 and voter 2 votes for candidate 1 wins. Therefore, the utility of both the voters is 1. They are saying that we want a decisive result. Whenever there is a decisive result, I have a utility of 1. Whenever the result is undecisive, the utility will be 0. So for these cells where there are decisive results, that is either candidate 1 wins, in this cell candidate 1 will win, in this cell candidate 2 will win, and in this cell candidate 3 will win. Why? Because voter 1 has voted for 3 and voter 2 has also voted for 3. So in this cell, the utility of both the voters will be 1. And in all the other cells, you see the election is undecisive. Therefore, the utility of both the voters are 0. Now it is clear?
Yes, sir. Yes, sir. Thank you, sir.
All right. So the next question is identify the Nash equilibrium for this game.
It's actually, I think that there are multiple Nash equilibrium in this game.
Okay, multiple Nash equilibrium.
There are 3 of these.
3 Nash equilibrium. All right. Which are the 3?
This is C1,
All right.
C1.
Before going to which are the Nash equilibrium, how do we identify a Nash equilibrium? How do we identify an? Sorry, can I just? All right, I just cannot go back. So how do we identify a Nash equilibrium? You can
using the
speak.
best response.
Right, using the best response. So what we do is we fix one strategy of the other player. So suppose V2, we are fixing strategy C1, and we'll see what should be the best response of player 1 given the player 2 has chosen C1. So this is how we write a best response, not expression, this is a notation, you can say. So it says that best response of player 1 given the action of player 2. So this is the action of player 2. All right. So we'll come here. We'll see what is the action of player 2. The action of player 2 is C1. What should be the best response? So you see, if the response of V1 is C1, the utility is 1. If the response is C2, the utility is 0. And if the the action is C3, the utility is 0. Is this clear? Is this clear?
Yes, so far clear. So far.
Yes.
Clear.
So the best response, you see, utility of player 1, when player 1 is choosing C1 and player 2 is choosing C1 is 1. The utility of player 1, when player 1 is choosing C2, given player 2 has chosen C1 is 0. And the utility of player 1, when it chooses C3, given player 2 has chosen C1 is 0. So what is the best response? You see, the best utility is coming when player 1 is choosing C1. So the best response of player 1 over here will be C1. All right. So this is the best response. And this will be the utility obtained for this best response. Similarly, we can do the same for player 2. So the best response of player 2 given, so we will see first this way. So given player 1 chooses C1, given player 1 chooses C1, what is the best response for, all right, just a minute. Okay, so this I have done for when the response of player 2 was C1. We have to do the same for C2 and C3 as well. All right. So best response, I just clear the area. Have I created some confusion here because I missed best response for other strategies as well. So what I'm saying is you have to obtain the best response function for different action sets. All right. So best response given player 2 has chosen C1, best response given player 2 has chosen C2, best response of player 1 given player 2 has chosen C3. Again, for player 2 you have to do the same. Best response of player 2 given player 1 has chosen C1, best response of player 2 given player 1 has chosen C2, and best response of player 2 given player 1 has chosen C3. So we'll do this one by one, then it will be clear. All right. I'll just take an eraser, erase this out. Again, we will do it. So I'll take blue color. So for this, best response of player 1 given player 2 has chosen C2. So player 2 is choosing C1. Player 2 is choosing C1. So what is the best response? We saw the best response is C1. Now we'll go to the second action, which is C2. So given player 2 is choosing C2, what is the best response? You see, this is the best utility. So the best response is then C2.
C2.
Right. Now, when the action of player 2 is C3, then the best response of player 1 is C3 because the
C3.
utility is 1. So C3. Again, we will do for the other player. Now, we will say the first player is actually choosing C1. What is the best response of player 2? You see, the utility is highest when
C1.
it chooses C1.
C1.
Similarly, this will be C2, and similarly, this will be C3. Now, what is Nash equilibrium? Nash equilibrium is the union of best responses. So you see, when this is the case for best response for player 1, this is the case for best response for player 2. This is a Nash equilibrium. Again, this will be a Nash equilibrium and this will be a Nash equilibrium. So there are three Nash equilibrium in this game. Any doubt? All right. So there are three Nash equilibrium in this game. So shall I move on, or some discussion needs to be here?
We can move on.
Okay, so before moving on, can we talk about Pareto optimality? What is the Pareto optimal solution for this problem? So I'll just move here for clarity. What is the Pareto optimal outcome or outcomes maybe? So what is a Pareto optimal outcome? You see, I'll just define Pareto optimality clearly. Yes, yes, you can speak.
So it's basically that given any outcome, if there is no other outcome such that all players can simultaneously improve their payoff.
Correct.
So
Correct.
this is so in this case, actually they cannot improve. There is no such other outcome.
So which are the Pareto optimal outcomes?
So actually all three are it is a multi-Pareto optimal. This is what I think. That all of these are gives the equal benefit. There is no choice which improves upon the outcome.
Correct. So you see, when someone is over here, you cannot deviate to any other outcome in all the 8 cells where both player benefits simultaneously. So this is Pareto optimal. Again, I just take another color. Again, when someone is over here, 1, 1, and you cannot deviate to any other outcome which simultaneously improves the utility of both the players. Therefore, this is also Pareto optimal. And when you are here, then also you have the same argument, and this is also Pareto optimal. All right. So this is how Pareto optimality is defined. So you can visualize Pareto optimality better if you see it in a graph. So we will just move over here and we'll draw one prisoner's dilemma. All right. So in prisoner's dilemma, it is clear to see what is Pareto optimality. So prisoner's dilemma, and we'll have player 1 and player 2. I just draw the payoff table. I will need some space, so I'll just. All right. So this is the payoff table. Confess, deny, confess, and deny. Sir has given the number, so I'm using the same number: -3, -3, 0, -4, -4, 0, and -1, -1. All right. I would need some space. I'm erasing these sides. All right. Now you see, you just draw a graph, and these numbers are in the negative side. So I'll just draw the third quadrant. All right. I'll just mark this is 1, -1, this is -2, this is -3, and I would need -4 as well. -4, -1, -2, -3, and -4. All right, and this is 0, 0. Now you just plot these points. So 1, -1. So this is -1. 1, -1, -1. So this is the first point. The second is 0, -4. So where is 0, -4? 0, -4. So this is one outcome. 0, -4 is this outcome. 4, and 3, -3, -3. All right. Is this clear? Or have I done any error? You can just speak.
No, that looks good to go. That's
okay. So you see how Pareto optimality is defined. You see, if you go from this point to any other point, suppose you are going from, so I'll mark these points A, B, C, and D. All right. So if you go from this point to any other point, suppose you're going from this point to this point. So you see, you are actually improving the utility of, so I'll just mark this is player 2 and this is player 1. So when you are moving from this point to this point, you are improving the utility of player 2. So you are going from -4 to -3, but you are worsening the utility of player 1. Similarly, when you are going from this point to this point, you are actually improving the utility of player 2. So the player 2's utility was -3, it is going to 0. But you are worsening the utility of player 1. So these 3 points are Pareto optimal. You see, when you are going from D point to any other point, both uh, utility are what am I saying? Yes. So what I'm saying is not these two. So when you are going from D to B, you see both the utility are changing. Sorry. I'm sorry, just 1 minute. This. Yeah. So what I was saying is, so you are trying to maximize the utility of the players. Right. Now in this game, the Nash equilibrium is this, and these 3 are Pareto optimal solutions. So this is the Nash equilibrium. I'll just draw a box, and these are the Pareto optimal solutions. So in this case, you'll just move from B to D, not D to B. All right. Okay, this has been saved. All right. So what I'm saying is you have to move from B to D, because this is the Nash equilibrium and you are moving to another point, which is D. So when you are moving from B to D, you are actually improving players 1 utility as well as you are improving players 2 utility. So these 3 points are becoming the Pareto optimal points. So for example, you have 2 functions, function 1 and function 2, and you have some points in the graph, many points. Now you see these points will become the Pareto optimal points. And if it is not clear, you can ask. These points will become the Pareto optimal points. I'm just drawing a line there. These points will become the Pareto optimal points, because if you move from this point to any other point, you are simultaneously decreasing the utility of both the functions. Or in the other way, if you are moving from this point to any point in the Pareto optimal point, you are simultaneously improving the utility of both the players. So the points in the outer edge of the graph, outer edge, becomes the Pareto optimal point. Similarly, the points over here in the outer edge of the graph becomes the Pareto optimal point when you are maximizing both the functions. All right. So this is the definition of, not the correct definition, textbook definition. This is how you understand Pareto optimal points. Is this clear, or have I gone too far? All right. You can just think about this. If you have any doubt, you can ask me in the next class. We'll discuss this clearly if you have any doubt. All right. So shall I move on, or you can ask me questions?
Yeah, you can do one, please.
All right. So this is the next question. So I have 2 players or individuals, I1 and I2, and they can contribute to a public good. So some public toilet or something like that, roads and all. So they can either contribute or not contribute. And this is the payoff matrix. The question is, what is the best response of I, first player, if player 2 chooses C? So we have discussed this. This is similar to the previous discussion we have. So if player 2 chooses C, what is the best response of player 1? You can speak.
Not contribute.
Not contribute. Any other answer?
Option A.
Option A. Now someone is saying option A. All right. Any other answer? So who has said option A? Can you justify why it is option A? or the other way around, who has said option B? Can you justify why it is option B?
Payoff is higher in the case of non-contribute for I1. It's 12, whereas in contribute it's just 10.
Right. So can you please speak up? Who said option C? I can just explain you why it is not option C. Not option C, option A.
Actually,
right.
I gone with previous example.
Yes.
As
Yes.
actually, the options are 10 and 10, so it has both the I1 I2 can have the intersection, so that I choose them.
No. So you see how this is written is, this is actually U1, U2. All right. So when you are over here, when you are saying that the player 2 will choose some specific strategy, so then you are only bothered about the utility of player 1 because player 2 has already chosen some strategy. So you will just, the player 1 will only bother about his or her own utility. So when he choose option C, he will get a utility of 10, or when he choose option or this one NC, then he gets a utility of 12. So suppose player 2 chooses C, the best strategy for player 1 will be to choose NC, right? Because in that case, he or she will get a utility more than what he or she would have gotten when she had chosen C. Therefore, the correct answer will be B. Is this clear?
Clear.
All right. Any other doubt? Okay. So this is the same game, same question. I just want to ask, what is the dominant strategy of player I? If there is a dominant strategy, and if the answer is yes, what is the dominant strategy? So first of all, yes. Sorry.
NC, sir, not contributing.
Okay. So, Acha, first of all, you need not tell me, sir. You can call me Shubham.
Okay.
Now, now, the thing I'm asking is, how do we know which is a dominant strategy, or how do we obtain a dominant strategy?
So dominant strategy is something which the player can choose despite like no matter what the response of the other player is, I should be at advantage.
Right. So how do we know which is a dominant strategy?
In contribute, if we see the player 1 can choose non-contribute, and in non-contribute also the player 1 has to choose non-contribute so that the payoff is higher. Payoff is higher in non-contribute case for both contribute or non-contribute of second player.
Correct. So I'll just repeat again what Roshni has just said. So irrespective of what player 2 chooses, so suppose player 2 chooses contribute, you see the utility will be higher when player 1 chooses non-contribute. Similarly, if player 2 chooses non-contribute, the utility will be higher for player 2, player 1 when it chooses non-contribute. So in both the strategies, we have seen that non-contribute strategy is better than contribute for player 1. Therefore, it is a dominant strategy. And in the first or in the second question, we had discussed the definition, not definition, just an intuitive idea of what dominant strategy is. Therefore, we conclude that NC is a dominant strategy for player I1. Similarly, if you just reason out, you will see that NC is also a dominant strategy for player 2 as well. All right, you can just reason out yourself. I'll move on. Now the third question, what is the Nash equilibrium of this game? I'm not able to hear anyone.
It's basically a non-contribute for both of the players, because
right.
for both the non-contribute is a dominant strategy.
Correct.
And that is where both this both the options come and circle get completed into that square.
Right. So you are now coming to Nash equilibrium with another definition. This definition which you are using is the union of the strategy of the union of the dominant strategies. This is where you are coming to Nash equilibrium. So you can come to Nash equilibrium by various ways. One is the best response. So when you are using the definition of best response to come to Nash equilibrium, this is one way to come to Nash equilibrium. Currently, what you just said is another definition of Nash equilibrium where you use the concept of dominant strategy. So wherever the strategies, dominant strategies come to one cell, that cell becomes that action set becomes the Nash equilibrium. All right. So this is the Nash equilibrium. Any doubts? All right. We'll just move on. Now, the next question which I'm asking is, what outcomes are Pareto optimal outcomes in this problem?
Contribute.
Contribute. Anyone else thinks otherwise? Yeah, you can speak. There's no issue if you are wrong. You can just speak. So is there any other Pareto optimal solutions in this problem? You see, 10,10 is Pareto optimal because if you are here, Nash equilibrium, you can just move to this solution and both the players' utility will improve. All right. So this is not the correct definition of Pareto optimality. Pareto optimality says that if you are at a Pareto optimal solution, you cannot move to any other solution such that both players' utility improve simultaneously. This is the correct definition, right? So if you are over here 10,10, if you move to this point 2,4, you see the first player's utility is decreasing while the other player's utility is increasing. Similarly, if you move over here, then first player utility is increasing, second player utility is decreasing. So there is no other strategy where both player is improving simultaneously. Therefore, this is a Pareto optimal point. All right. This is not a Pareto optimal point because if you move to this strategy, you see both the both the players' utility are improving simultaneously. So this is not Pareto optimal. But these two are also Pareto optimal. You see, when you are over here, and if you move to any other strategy, suppose you are moving from here to here, you are decreasing the first player strategy, utility, but you are improving the second player's utility. So you cannot move over here. Similarly, you cannot move over here. Similarly, you cannot move over here. So there is no other strategy where you can move from this strategy such that you improve both players' utility simultaneously. So this is also a Pareto optimal point. This is a Pareto optimal point. Similarly, this is also a Pareto optimal point. So this is what I was explaining before in the graph. So actually the outer edge becomes the Pareto optimal points. All right. So this is for player 1, utility of player 1, and this is utility of player 2. So these points 1, 2, and 3, these points are actually the Pareto optimal points for this game. Any doubt? Any doubt regarding why these two are also Pareto optimal? The Pareto optimal concept is not very easy to get. It is a little bit confusing. So if you have doubt, you can just ask me. So this is how you can understand. Suppose you are at this point and you want to improve the utility, you can either move, you have to move to some other point. So if there some other point is there, so this is not a Pareto optimal point, because there is a point where you can just move and improve both of these strategy. All right. So this becomes a non-Pareto optimal point. So I'll just move on. So this is a problem. Okay, I have just named this problem public goods game, but this is an auction game. So all right, so this name you just forget it. So this is a first prize auction. So what is the first prize auction? There is an object which some bidders want to get, and whoever bids the highest bid gets the object, and he has to pay that highest bid. So there will be bids BI, and whoever bids the highest bid, he has to pay that same bid amount, right? And that player's win. This is the first prize auction. There is something called second prize auction as well, and you have an assignment on that. I have a question for that as well. We will discuss about it. So this is a problem of first prize auction. There are two individuals, or yes.
Before you go in the videos that was uploaded for the week 1, the first prize auction wasn't covered. So I would request you to be little, deliberate here, because I have not understood. This wasn't there in the part of the videos, or may I may have missed it.
No, this wasn't there as a part of the video lecture. This is because this is a game and we are talking about the concept of a game. That's why I have brought this problem over here. This is because you will get an idea of how to solve various other problems as well. That is why I have brought this problem over here.
Yeah, and because there are in the quiz, there are 8 questions which were somehow related to something which wasn't there part of the videos. Like there were 2 or 3 questions.
And this is why this problem solving sessions has been scheduled. You can discuss about those problems over here. All right. So I'll just explain what a first prize auction is clearly then. So there is one object which some bidders wants to get. Suppose there are 3 bidders, bidder 1, or I'll just say player 1 because I have named the players over here as P1. So there are bidders P1, P2 and P3. There are 3 players and each has some bids. So player 1 will have P1 in some set. So over here the set is 0, 5, 10, 15. Similarly, bidder 2 can have some set. It can be same or it can be different. And bidder 3 can also have some values in a set. All right. Each player will bid an amount one by one, and there will be one person who will monitor this bid. Whoever gets the highest bid wins the auction or wins the object in the auction, and that player has to pay that amount to the company such that, or not the authorities, to obtain that object. All right. So this is how a first prize auction is done. Is this clear?
Yeah.
Okay, so we have a problem over here where there are 2 bidders and the bid amount is from this set 0, 5, 10 and 15. The object is worth, so you see in auctions generally the object is maybe antique or such things whose absolute values or absolute worth is not known to people. That is why people bid, and they bid for an amount which they think is appropriate for that object. And each bidder will have an upper limit that he will not go beyond that value because he thinks the object will be overpriced beyond that point. So this is what the worth over here mentions, that player 1 thinks that the worth of this object is 10 and player 2 thinks the worth of this object is 8. All right. So this is what worth is. Now player 1 bids an amount of 10 and player 2 bids an amount of 5. Now the question is, what is the utility of player 2? Utility of player 2 when player 2 is bidding 5 and player 1 is bidding 10. So if you remember, we write utility like this. Utility of player I when player I is choosing an action AI and all other players are choosing an action A minus I. So the first term is always of player I. So over here, this is bid of player 2 and this is bid of player 1. So this is simply what is the utility of player 2. So this is the question. All right. So what will be the utility? Maybe you can just reason it out. They have to pay something and in return they are getting something, right? And this object is some worth to that person. So what will be the utility or what will be the net worth or net gain they are making? That will become the utility. So you can just speak. No matter what you speak, just contribute to this discussion.
The question is for second player, right?
Yes. So when I write U2, we are asking the utility of player 2.
Okay, then it should be 0.
Before that, just tell me what will be the expression of a utility. The utility of player 2, what will be the expression?
Okay, it will be how much he pays minus how much, how much is the product's cost for him minus how much he's paying for it. 8 minus 5.
All right, so it will be 8 minus 5 because this is the worth which he thinks he is getting and this is what he is paying.
Yeah.
So this is coming out to be 3. So why are you saying it is 0?
Because player 1 wins the bid over here, so player 2
Correct.
is not going to pay.
Correct. So this is not the correct utility. This utility will be obtained provided. So I'll just erase some line. So the utility function will be written like this. This is the utility if player 2, just write P2, player 2 wins. If he doesn't win, then it becomes, utility becomes 0. All right. So utility is 0. So any doubt why is the utility 0? Because this is what he gets ultimately. He gets 0 if he loses the auction. Is this clear? If he would have won, then the utility would have become 3. But since bidder 1 is winning, he has the highest bid, so he is winning or she is winning. Therefore, the utility which player 2 is getting is 0. He is not losing something, he is not gaining something. Is this clear? I hope it is clear as no one is speaking. So I'll just move on. So this is the same problem. I am sorry I have not corrected the topic name. So now it is the same problem. I have just changed the worth. Now the player 1's worth is 12. Player 2 is same as 8. So what is the best response of player 2 given player 1 bids 10? So this is a different question than before. We are not asking about the utility of player 2. I'm asking about what is the best response of player 2. Note that when it is a tie, player 1 wins. Suppose player 1 has an upper hand than player 2, more rich, something like that. So whenever there is a tie, player 1 wins. This is the case. So let us write the utility of player 2. So utility of player 2 when what is the best response? We want to know the best response. I'm not writing the action of player 2. Given player 1 is choosing 10. So you see, when player 1 is choosing 10, when will he win? He will win when he bids more than 10. He cannot win when he bids 10. If he bids 10, you see, player 1 will win because it is a tie. So suppose player 1 is bidding 10 and player 2 is also bidding 10. In this, it is a tie. So when it is a tie, player 1 will win. So player 2 will not win. All right. So when will player 2 win? He will win when he chooses a utility of, a bid of 15. So when the bid is 15, the utility of player 2 will be, so the worth is 8 and he's paying 15. So the utility will be minus 7. All right. Again, when he bids 10 and player 1 bids 10, the utility will become 0 because he is not winning. When player 2 is bidding 10, it is a tie and player 1 is winning. Therefore, the utility is 0. Similarly, when he bids 5, again, when he is bidding 5 and player 1 is bidding 10, player 1 is winning the bid. Therefore, the utility is 0. Similarly, when player 1 is bidding 10 and player 2 is bidding 0, then the utility will be 0 because player 2 will not win the bid. So this is the various utilities when he chooses various actions. Is this clear?
Yeah.
Any other person can also speak if you have any doubt. You can just speak and say, yeah, all right, no problem. That will also work. All right, so this is the different utilities for the different strategies player 2 is choosing. So player 2 can either choose from 0 from the set. It can either choose 0, 5, 10 or 15. So we have obtained the utilities for various actions player 2 is taking. Given player 1 has chosen 10. Remember, it is given that player 1 has chosen 10. Now you tell me what is the best response of player 2. So I've helped you a lot. Now I expect you to give me an answer for this. What is the best response of player 2?
Can there be multiple best response or only one?
Think about it.
But is there a way of not bidding, because then he doesn't bid? He is either getting 0 utility or he's getting minus. So his best response is to get the 0 utility, not to
Right.
not seek to get any utility out of it.
So
So
there is a game, both are playing. So you just think about both should play. And anyway, if the utility is 0, it is same as he is not playing. So doesn't matter. So the idea is the game is going on and these are the strategies the player can opt for. These are the sets from which a player can opt for one of the strategy. So what is the best response he can take?
it's to give 10, because what happens is while he or she is driving 0 utility out of it, he's ensuring that the other party is paying maximum.
So the logic you are thinking is yes.
Yeah, no. I'll come back after this clarification.
Okay. So what I'm saying is, it is given over here. It is given that player 1 is choosing 10. So you're not changing that part. That part is fixed. Whenever you obtain a best response function, the action of other players is fixed. That is how a best response um, is derived. So you are fixing the strategy of the other players. So no matter what the bidder 2 chooses, bidder 1 will bid 10. That is what it means. Therefore, what should be the best response of player 2? That is the question I'm asking over here.
I have one doubt over here.
Yes.
Yeah, so the best response of player 2 should be some value which is not dependent on player 1's value, right?
No, player 1's value is fixed. Dependent
in the
on
previous
that value. Yes.
Like in the previous example, no matter if, yeah, so here, yeah, in this example, like if we are finding the best response of I1, we have to find like what he has to say no matter what I2 chooses. Like even if I2 chooses contribute or no contribute, my response should yield the maximum value.
No, that is why I had first in the second slide, I had discussed the definition of dominant strategy. What you are saying is the definition of dominant strategy and not best response.
Okay, got it.
All right. So what you are
Yeah.
having in your mind is the definition of dominant strategy and not best response.
Oh,
Best response is when
Best
you are fixing the value or not value, the action of a player or the other players, and then you are determining what should be the best strategy for this given player. All right.
okay, okay. Yeah, got it.
Okay, so we were here. Okay, now coming back again, what should be the best response? You can speak. You may be wrong, you may be correct. Doesn't matter. If you don't speak, you will not learn. So you can speak anything you want related to the subject, of course. I know where the
Anything?
confusion is. Yes, yes, speak.
Yeah, like all 0, 5, and 10, all three seem like the best responses.
You are correct. So this is where the confusion is, and that is why I have placed this question over here. There are multiple best responses given player 1 is choosing 10. Right? There can be multiple responses. So it will be, this is not how you write. I have written it incorrectly. So you can write it like this. This is not important for you, but since I'm writing over here, I should write correctly. So you should write best response of player to give any symbol, say X, it belongs to 0, 5, and 10. So this best response can be any value in this set. All right. MBC, you had some confusion, I guess. Is it clear?
Yeah, this is now clear. And this is logical. Pardon me because I didn't have any knowledge on this. So that
No
was
problem. So you see, we are all learners. I am also learning with you. I can also make errors. So I request you, if I make an error, please point out to me and just tell me. So don't need to say sorry. You can make mistakes. This is how we learn. We learn much more by making mistakes as compared to when we just do things correctly. So I expect you to make some errors. The questions over here in this problem sets are such that you make errors. Right?
Shubham ji, I mean, like, will the
Yes.
whole course be completely problem solving? Like, it needs a background in math.
Not exact. You don't need a problem. Sorry, background in maths. I am writing these notations because I think it is correct and I should write it. There is no need for you to use these notations.
Okay, so I mean, like, it will be, we will be able to manage with some basic understanding of math, right?
Yes, yes. If you want, you can just go through the concept of sets.
Okay.
Okay, it's not necessary. Since you asked, I'm saying because sets are very essential. You see, I have written a set over here. What does it mean when I write this? So these
Okay.
concepts are coming from sets. It means that an element from this set 0, 5, and 10. It can be any element that belongs to so X. So this means X is an element which belongs to this set. And what
Okay.
is the element of this set? 0, 5, and 10. That is what I have written over here.
Okay. And will this recording be available if you want to view it again?
Yes, yes. This recording will be available to you anytime you want. You can just watch it.
Certain things, if we are not able to understand it right away, we can watch it again.
You
Thank
can
you, sir.
ask me
Sorry
in
for
the you can ask me in the next class also. There is no
Okay.
restrictions in just I'm here to clear the doubts.
Thank you. Thank you.
All right, and again you can call me Shubham. All right, so the next is market competition. So we have two firms, F1 and F2, and they can set prices P1 and P2. The cost of production is 0. So suppose they are getting something, and it is hypothetical, so it may not be the case in real life. For this example, we are saying that the cost of production is 0. So whatever they are selling, they have procured it at 0 cost. The market price is determined by the lower of the two prices. So whichever firm sets the lower price, the market will move to that firm, no matter how small the difference in price is. All right. So whoever sets the lower price, the market will move to that firm. If both sets the same price, they share the market equally. All right. So the market will be divided equally between them. What is the Nash equilibrium? If the prices can be 0, 5, 10, and 15. So these are the, so P1, P2 can be, so again, it can be from the set 0, 5, 10, and 15. It means it can take any one value in this set. What is the Nash equilibrium? If you are not getting, I can just walk you through, but you have to speak. I'll not understand it. I'll just solve and move on. All right. So think about it. Suppose, I'll give you 1 minute to think.
It's 0.
Okay, so there's one person saying 0, 0. We'll see if this is correct or not.
So each of these players will have 4 options.
Yes.
And like P1 will have 0, 5, 10, 15, and give for 0, it's like it's 0. For if he sets 5, then it is 5. So I think each of the options will have, each of the player will have to first, given that what option he is choosing, and then the second player will have an option. That's my thinking.
Okay. Okay. So you're saying something like this. Something like this.
Yeah,
Am I correct?
That's true.
Okay. Any other answer you may think is, I'll write it down and then we'll discuss all the answers. Any other answer you are thinking? All right. So now let's discuss. You see, what so can you just tell me your name? MB Singh. It's weird to say.
That's fine. So this is what I was thinking, that each of these given problems, each of the given options will have a Nash equilibrium, not one, maybe having more. In fact, I'm just thinking through it.
Okay. So shall I discuss the answer or do you want some more time?
No, please go ahead.
All right.
Nothing is coming in.
Okay. So we'll just reason it out. You see, before that, what you were saying that suppose player 1 is choosing one value, suppose 5, then the player will say that I will also choose 5. Similarly, if some player is choosing 10, the other player will say I will also choose 10. This is what you were thinking, right?
Yes. So game table, like let's say we could have made the game table, and
Yes.
player 2 could have made the option, let's say whatever, for each of these options there'll be a game table.
0, 5, 10, and 15. 0, 5, 10, and 15. Right. So player 1 and player 2. Okay. Now, so what will be the profit? Profit will be this. This is the prices. So this will be the profit because the cost price is 0. So whatever the price is set, that is the value they are obtaining. All right.
Yeah, that's true.
But it depends upon the market. All right. So if it gets 0, then 0 market share, then it gets a 0 utility. If it gets market, then it will be equally divided. All right. Now, what I was telling you, so when you say that a player is setting a price X and then the second player is acting upon that price, that is a different game altogether, and that is known as sequential game, where the strategy of one player is already done. So he has already fixed his strategy, and then the second player is knows that this will be the strategy, and then he acts upon that strategy. All right, that is known as a sequential game. But whatever we have discussed till now is known as simultaneous game. All right, I'll just write it over here. sequential game, and simultaneous game. So what is a sequential game? In a sequential game, one player has already executed his action, and then the second player sees, okay, this is what the first player has done. Now I will do my action. So this is a sequential game. In simultaneous game, both of the players choose an action simultaneously, and that is why we have such interesting observations. So let us come back to prisoner's dilemma. Okay, let us come back to prisoner's dilemma. We will see and we'll understand the difference between a sequential game and a simultaneous game. So we have confess, deny, player 1 and player 2. I'll come back to this question. All right, I'll just come back to this question. -3, -3, 0, comma -4, -4, comma 0, and -1, comma -1. Or prisoner's dilemma, is it appropriate? Just let me think about it. No, prisoner's dilemma is not an appropriate problem. Sir has given one more problem, right? What was that problem? Just 1 minute. Just erase it. What was that name?
Battle of Sexes.
Battle of Sexes. Yes. Battle of Sexes. Let's write the table for that. Battle of Sexes, or maybe what I'm trying to tell you is maybe subtle difference. Battle of Sexes, will it? Let me see if Battle of Sexes give that subtle difference. You will see what the difference is actually. Okay. Let's move on with prisoner's dilemma. If that is not the case, then we'll see if I'm able to explain to you the difference. Okay. So the prisoner's dilemma is such that we have -3, -3, -4, 0, 0, -4, and -1, -1. Now what I'm saying is, suppose one player has already chosen deny. The other player knows that he has chosen deny, and he wants to see what should be his best response. So in sequential game, we don't know the best response of the response of the other player. That is why we go through all the actions of the other player. We are saying, suppose let us assume that the second player is choosing deny. What should be my best response? Over here, when the second player is choosing deny, the best response of player 1 is confess. Similarly, when the player 2 is choosing confess, the best response is confess. All right. So this is how we do sequential game. We are fixing both the strategies, but in simultaneous game, one strategy is already told you that suppose it will only choose deny, not confess. Now what should be your strategy? So this is how a sequential game works. All right. So I can just modify this example to quickly tell you what will be interesting about it. You see, suppose this is 0 and this is suppose +1. This is +1. So this is not a prisoner's dilemma. All right. So when this is +1, you see, when we are given that player 2 will choose deny, we know for sure that player 2 will choose deny, then it is best for us to choose deny. But when we are not sure whether it will choose deny or confess, then we don't know if this is better or this is better. Am I being ambiguous, or you are getting the difference between simultaneous game and sequential game? In sequential game, you know that
we're getting that simultaneous and sequential. That's fair enough. That's fair enough.
Yes. So I am not able to give you an appropriate example right now. All right. So let us move to this problem. You see, over here, when a player chooses 15, suppose player 2 is choosing 15. Now, what is the best response of player 1? The best response of player 1 will be to choose anything from 0, 5 and 10. Again, when player 2 chooses 10, what is the best response of player 2? The best response of player 2 is 0 and 5. When player 2 chooses 5, the best response of player 1 is 0. And when player 2 is choosing 0, the best response of player 2 is 0. You can just do this for the other way also. So you will see 0, 0 becomes Nash equilibrium. 0, 0 becomes Nash equilibrium. I'll just tell you why, but this is the logic. You see, if player 2 chooses 15, player 1 will try to go lower, either 0, 5 or 10. When player 2 chooses 10, it will go lower, 0 and 5. When player 2 chooses 5, it will go 0. And when player 2 chooses 0, it will again go 0. So this is where this is the utility where it is getting highest utility. Similarly, on the other case, when player 2 is choosing 15, player 1 is choosing 15, player 2 can either choose from 0, 5 and 10. Now if it chooses 10, it can either choose from 0 and 5 again. When it chooses 5, it will have to choose 0. So these two will become self-enforcing. 0, 0 will become self-enforcing. These will not. And on that matter, anything other than that will also not. 5, 10, 10, 5, and anything else will also not be a Nash equilibrium. This will be the self-enforcing strategy, 0, 0. And therefore, this is the Nash equilibrium of this game. Is this clear? Because the firm will know, firm says, okay, let us choose 10, in the hope that the other firm will also choose 10. It might not be the case. If it chooses a lesser price, they will get the whole market share. So the best thing which both the firms can do is to choose 0, 0. Is this clear?
So far understood.
All right. So the lecture will move on to sequential game ultimately. So you'll understand the difference between simultaneous and sequential game consecutively. Any other person who has some question in this? All right. So we'll move on. So this is next problem. 3 firms, F1, F2, and F3. Okay, so this is a similar question than before. You can take 1 minute to read and then give me an answer. I'm not reading. You just have to find the Nash equilibrium of this problem. So over here,
they will choose low. They all will choose low. That's going to be the Nash equilibrium, and that's going to be self-enforcing.
Yes, correct. So over here, you will not be able to draw the table because it is a 3-dimensional table, but you can just reason it out like the way we just reasoned out in the previous problem. What is happening? You see, if a firm chooses high price, the other firm will try to choose a lower price than that firm, because in that case the utility will be higher. You see, if all firm chooses high, they get 10. If one firm chooses low and the other chooses high, the firm which chooses low gets 20, but the other gets 0. So there is a risk in choosing high. They will think, if I choose high and the other person chooses low, then I might have a chance of getting a utility of 0. On the other hand, if I choose low, I will get a utility of 10. So this seems the logical thing to do. So all the 3 firms will choose low, and that is why that becomes self-enforcing. Any doubt? All right. So this is a problem which you have in your assignment, and I have taken a very similar problem. I am not allowed to solve the problem, the same problem which is there in your assignment. That is why I have modified that problem a little bit, and we'll see to what extent I'll solve this problem. All right. So there is some gray area over here. All right. There are two people, P1 and P2, and they are engaged in a joint project. Each person I puts an effort from this set. So it means xi can take value 0, 1, 3, 2, and 3. So if you have this notation doubt also, you can just stop me and ask. All right. Which costs? So this is the effort it is putting. So any one of these value from this set, and it will cost him or her xi square. So suppose the first person is putting x is equals to 2, then the cost which he or she will incur will be 2 square, which is 4. All right, and so on. The profit or the revenue from this project will be f x1 comma x2. So this just means the value is dependent upon both x1 and x2. If you don't know a lot of mathematical notations, this just means that it says that it will obtain 2x1 x2 plus x1 plus x2. So this is the value or the revenue which they will obtain, and it will be split equally. So for each one it will be by 2. If you want to get the utility of one player, so suppose utility of player 1 where he chooses x1 and the other player chooses x2 will be 2x1 x2 plus x1 plus x2. So this will be split equally. So it will be by 2. And what is the cost? This is incurring, player 1 is incurring, it is incurring this cost. It will be x1 square. Is this utility function clear for player 1? Similarly, it will be for player 2 as well. I'm just writing it again. You just check and tell me if it is not clear. Just check and tell me. All right. So the question is, what is the best response of player 2 given player 1 is choosing 1? Just figure out and tell me. I'll just check what is in the problem or assignment in the website.
X2 is 1.
X2 is 1. Okay. Any other question? Oh, sorry. Any other answer you want to?
It's 1.
1. Okay. Okay. So before I tell you, can you tell me how are you obtaining 1?
By calculating that utility function when x1 is 1.
Okay. So you are saying that you are putting the value of x1 as 1.
And
you have
x2
to
I'm
obtain.
changing as 1 and 2.
Yes. So you want to obtain the utility of player 2. Therefore, you will use this function, not this function. All right. You will use this function. You are putting x1 value as 1. You are putting the value over here and over here. And then what you are doing?
Sorry, sir. Can you?
I'm saying that when you are putting the value of x1 as 1 because it is given, you have obtained a function of utility for player 2. Now what you are doing?
Then I'm first substituting x2 as 1 and then next substituting x2 as 2.
Okay.
Separately and fine.
Right. So that is how you are doing, but that will not give you best response. All right. Although I have written only 2 values of x1, x2, you have to check all values. For best response, you have to check all values. All right. So over here, although I have given only 2 values, 1 and 2, and obviously the answer will be from these 2, but since player 2 has more strategies, you have to check for all the strategies and then you will know which are the best response. As you have seen in the previous example, there can be multiple best responses. So you have to check from all the strategies. So the strategies of x2 can be either 0, 1, 2 and 3. To obtain all the utilities, I mean you have to obtain x2 0, 1, 1, 1, it will be 2, 1 and 3, 1. You obtain all these values, and whichever gets the highest value, for that you check the strategy, and that strategy becomes the best response. Obtain these values and check again.
Okay.
All right. So if you check, so I'll just write one expression. So u2 for x is equals to 1. What it will become? It will become, when you put x is equals to 1, it will be 2x2 plus 1 plus x2 minus x2 square. So this will be the function which we will use to put different values of x2. You will put 0, you will put 1, you will put 2, you will put 3, and then obtain which is the highest value or highest utility player 2 is obtaining. And what is the answer?
I think still 1 seems like that.
Yes, 1 is the correct answer. So I'm not solving it over here because this is your assignment problem, not same, quite similar. So just solve and check. I'm just telling over here 1 is the correct answer. All right. Shall we move on, or any doubt?
No doubt.
Okay, so we'll move on. So this is the same question. Now over here, I have given you some responses or some outcomes. So these are outcomes. You just have to tell me what are the Pareto optimal outcomes. So you have some outcomes. And how do we know what are Pareto optimal outcomes? You have to obtain, the utility of the players. So for example, you have a value 2, 3. So when I'm writing 2, 3, 2, 3, it means this is for player 1 and this is for player 2. Similarly, when I'm writing 3, 2, this is for player 1 and this is for player 2. All right. Now, what you have to obtain? You have to obtain the utilities of the players. So you obtain u1 of 2, 3, u1 of 3, 2, and u2 of 1, 2. Similarly, you obtain u2. Now, please pay attention. When I write 3, 2, this is for player 2 and this is for player 1. So be mindful, all right? 2, 3, and this will be 2, 1. Why 2, 1? You see, when I say 1, 2, this is for player 1 and this is for player 2. Therefore, this is for player 2 and this is for player 1. You obtain these values. You obtain these values and then you have to check utility which is Pareto optimal. So these utility will come together. How will it come together? You see, when player 1 is choosing 2 and when player 2 is choosing 3, find the utility pairs. All right. Similarly, when player 1 is choosing 3 and player 2 is choosing 2, find the utility pair u1, u2. And when player 1 is choosing 1 and when player 2 is choosing 2, get the utility pair. When you obtain these pairs, you can check Pareto optimality. We have discussed about Pareto optimality. You see which solution is Pareto optimal. And then you can tell either this is Pareto optimal, this is, or both, or you can answer this question. You try. If you are not able to do, I'll just try to help you out. I'll just check if this is one of the assignment or not. Okay, so I see that you don't have a Pareto optimal problem on Pareto optimality for this problem. So I'll just help you solve this problem completely. Before that, you try. And over here, you just have to bother about these 3, 1, 2, and 3. Because that is given in the multiple choice. If it is not given in the multiple choice, then you have to check for all combinations of this value 0, 0, 0, 1, and multiple values, all combinations, and then you will have to obtain the Pareto optimal points. Since we have been given these points, then we'll only work out for these points. So I'll help you out. Okay. So you see the utility function over here is changed slightly. The previous problem, the utility function was this function, revenue function was a little bit different. So let us write. All right. So f of x comma x1 comma x2 is x1 x2 plus x1 plus x2. All right. And cost function is c of xi is actually xi square. And this function is split equally between the players. So what will be the utility of player 1 given x1 comma x2? This will be split. So we'll have x1 x2 plus x1 plus x2 by 2 minus x1 square. Similarly, utility of player 2 will be x1 x2 plus x1 plus x2 by 2 minus x2 square. Is this clear? Now you have been given three values, x1 comma x2 as 2 comma 3, x1 comma x2 as 3 comma 2, 3 comma 2, and x1 comma x2 as 1 comma 2. Okay, you see three values, 2 comma 3, 3 comma 2, and 1 comma 2. So obtain the values of u1 and u2 for these three values. So when x1 comma x2 is equals to 2 comma 3, so u1 will become so it will be 6 plus 5 by 2 minus 4. So this will be 6 5.5 1.5. All right. If I make any error, you just point it out. All right. And utility of player 2 will be 6 plus 5 by 2 minus 9. It will become 5.5 and minus 3.5. All right. So u1 comma u2 is 1.5 comma minus 3.5. All right. This is 1. The second, when x1 comma x2 is actually 3 comma 2, then u1 will become same 6 plus 5 by 2 minus 9, which is equals to minus 3.5, and u2 will become 6 plus 5 by 2 minus 4, which is 1.5. So the second u1 comma u2 will become minus 3.5 and 1.5. And when x1 comma x2 is 1 comma 2, then u1 will become 2 plus 3 by 2 minus 1, which is 5, 2.5, 1.5, and u2 will become, so it is again 5 by 2 minus 4, plus 4, will be minus 2.5 minus 4 is 1.5. So u1 comma u2 will become 1.5 comma minus 1.5. Is this clear? Is this clear?
Yes.
Anyone has doubt in whatever I have done over here? Okay, so we have 3 points. I'll just erase a little bit. So we have 3 points. The 3 points are, the 3 points are 1.5 comma minus 3.5 minus 3.5 comma 1.5 and 1.5 comma minus 1.5. Now you see from which points you can just improve. If those points you can improve, then those are not Pareto optimal points. Just check this one. So you see the first player is obtaining 1.5 and the second player is obtaining minus 3.5. And if you move to this point, you see the first player is remaining the same, but the second player is improving. It is going from minus 3.5, it is going to minus 1.5. So this is not Pareto optimal, not Pareto optimal. All right. Now is this clear why this is not Pareto optimal? Because you can just move from this point to this point and improve the utility of one of the players while remaining the utility of the other player as same. So this is not Pareto optimal. Is this clear?
Yeah.
Any doubt?
Yeah, so far so good.
Okay. Now for this point, minus 3.5 and 1.5. You see, you cannot move to this point, nor can you move to this point. You can just confirm. So this is Pareto optimal, and same for the case for this. This will also be Pareto optimal. So therefore, these 2 points, whichever value from which we have obtained, so these 2 points are 3, 2 and 1, 2. So therefore, 3, 2 and 1, 2 are 2 points are Pareto optimal points. So this is the correct answer. Is it clear?
I have one doubt.
Yes.
In this case, are we not checking when x and x i's are 0, 0 or something? Because in case
Right.
we can.
So we have to check. We have to check. You are correct. We cannot just say that these are Pareto optimal points unless we have checked all the other points. But since that will become cumbersome, you see, we have 4 cross 4, 16 points actually. So for all 16 points you have to obtain. So for the sake of simplicity, I'm just saying check for these 3 points. And among these 3 points, tell me what are the Pareto optimal points. But you are correct. We have to check for all 16 points. 0, 0, 0, 1, 0, 2, 0, 3, 1, 1, and every other point.
Okay. Okay, so there is no like no other short trick or some graph method, not graph method, using the diagram which you had
Yes.
mentioned earlier.
So that diagram is just plotting of these points. You have to obtain the value of this point using whatever we have done over here. When you have this point, you can just plot and then obtain the Pareto optimal points. But these values you have to obtain using whatever we have done right now. The same exact thing you have to do.
So we cannot predict what comes at the corner of the graph.
No, no.
Okay, okay.
There can be some other tricky algorithms which uses some tricky concepts or something like that. But until and unless you have the whole set of points, you cannot tell which points are Pareto optimal points. You have to have the whole set to tell which points are Pareto optimal.
Okay, so in case during the exam we get these types of questions, we are supposed to check only among the options which are given to us.
I don't think someone will ask you to check for 4 cross 4 or 5 cross 5 points. Yeah.
Fine. Yeah.
And anyway, you have 4 options. Anyone should be correct. So you can be clever and just check these points.
Okay. Yeah.
Any more doubt? Okay, so this is also an option. Let me check. Okay, so this is second highest bid. So we'll have to discuss what is the auction where second highest bid wins. So this is a little bit different bidding than what we have seen in the first highest bid. All right. So in this case, there is one object and there are multiple players. All right. So for the sake of simplicity, let us let us assume there are 2 players. All right. Now, whichever players bids the highest, so highest bid wins. Highest bid wins. But this is where it becomes different than the what we have seen earlier. Even though the highest bidder wins, he has to pay the second highest bid. He doesn't have to pay his own highest bid, he has to pay the second highest bid. This is what this kind of auction is. This is known as second prize auction. Is this clear?
Yeah.
And by the way, it can be any, not 2 players, it can be n players as well. Then also he has to pay the second highest bid. All right. Highest bidder wins, but he has to pay the second highest bid. So this kind of option is there in your assignment. So there are two players in this bid. The bids are either 0, 10. So BI can be from the set 0, 10. It can be only from this set. The item is worth 20 for C and 10 for D. All right. The winner pays the amount of the second highest bid. What is the utility of player D if player C bids 10 and player D bids 0? So B of C is 10. C is bidding 10 and D is bidding 0. So you have to find the utility of D.
Oh, should be 0.
Okay, so there is one answer, 0. We'll see if it is 0 or not. Any other one, any other answer you want to give? You can take your time, you can ask me questions. It's not an issue. Okay, so let us see what happens. When player C is bidding 10 and player D is bidding 0, who is winning? Player C is winning. So when player C is winning, D doesn't lose anything, doesn't gain anything. So the utility of bidder D is utility of bidder D is 0. Now tell me what is the utility of bidder C? I should have mentioned over C here maybe. Okay. What is the utility of player C?
10.
10.
It's basically, but what is the meaning of the he pays the second highest bid?
Right.
Like
So
second highest bid in the sense is in case if he has bid 10, then the second highest bid is a 0.
Yes, so he will pay
So
0 actually.
he pays 0, and if he pays 0 and the item is worth 20 to him, so for him the worth is 28.
Yes, yes. But here the worth is actually for him it is okay, 20, right. So this will be 20.
I stand corrected. It's
Yes,
other
yes.
way.
Yes. Yes. So again, if there is a confusion, I'll let you know what happened. You see, player C won. When player C won, he has to pay the second highest bid. What is the second highest bid? It is 0. So he has to pay 0. Now the worth of that item to him is 20. So the utility will be 20 minus 0, which is 20. Is this clear?
Oh, got it now. Yeah.
All right. So we'll move on. So what is this?
Now, can
This
you
is,
just go back
yes,
one step? This is so basically this is what it is. Like he pays 0, and obviously the item is worth 20 to him.
yes.
Right. Okay, please move.
So two players A and B are competing for a prize worth 8. So both the players have the same worth in this game. Each player can choose to stay in the competition. Okay, so this is not an auction. I'm telling you, this is a mistake from my end. This is a problem which you have in the assignment as well. This problem is known as, just let me check, attrition, a war of attrition. I'll just change these corrected things and then upload the slides. All right. This is a war on attrition. I made this in a hurry. That's why these errors. Okay. So what happens in this? You see, in this kind of game, there are, suppose it is a boxing match. Now in a boxing match, players can stay. So suppose one round, is one hit. So when somebody hits, that is one round or something like that. So for each time period, everybody loses. So everyone loses. So suppose I am in the match, not a boxing match. Just think about it that if we stay, we lose. And if we don't stay, then we'll see what happens. It is a multi-period game. There are multiple periods in this. So both the players are trying to stay as long as they can. And whoever stays the last wins the object. Is this clear? In a war of attrition, there are two players and they have to stay as long as they can. Whoever stays for longer time, he gets the object and win. But the caveat is, for each time period they are staying, they are actually losing something. So suppose they are losing energy or they are losing some amount or something like that. So if they stay for longer, they are losing larger amount. If they are staying for less amount of time, they are losing less value. But whoever stands last wins the game. All right. Whenever somebody leaves, suppose player B is leaving, then player A wins. Is this clear? War of attrition.
Yeah.
Yeah, please. We will move.
Yes. So there are
And
two.
one doubt, one thing.
Yes.
So this cost of two is deducted from the price, or is it like not in
It is.
terms of like?
It is their value. It is their cost. So whether or not they wins the prize doesn't matter. They have to pay the cost.
Okay, so even if they lose, they have to pay it.
Pay the cost. Correct.
Okay.
Okay, so I'll just read the question once again. There are two players, A and B. They are competing for a prize worth 8. All right, so the competition is this attrition. Each player can choose to stay in the competition for 1 or 2 rounds. So over here, I have limited the number of rounds to 2. It can be an infinite game as well. All right. Each round, a player incurs a cost of 2 by staying in the competition. The player who stays the longest wins the prize. What is the expected payoff of player A if player A stays for 2 rounds and player B stays for 1 round? So player B is actually moving out of the game in after round 1. All right. So what is the payoff of player A? What will be the payoff of player A? This is the question.
So for him, it is 2 rounds that he's playing, and for each round he's incurring a cost of 2. So that
Okay.
means for him the payoff is 4. 8 minus 4 is
Not payoff, cost.
cost
Okay,
is 4. Yeah, exactly.
4, yeah. So you are saying 8 minus 4 is 4.
Is 4.
Okay. Any other answer?
The only thing is, the only doubt here is that, like, let's say the B only has stayed in the game for 1 round. So,
Okay.
so for second round, does the A actually incurs a cost, or because there is no other player, so he does not incur a cost? Just my doubt.
So that is where the trick of this question is. Think about it. Think about it.
So I think it is 4 is
Okay.
what is his worth is.
Okay. So I have actually played with the English of this problem, right? Okay. Any other answer?
Because if it was a 2-player game, now if we
Okay.
are getting into semantics, if it is a 2-player game, the game can only go on as long as there is a second player. So the
Correct.
game will terminate at the termination of first round.
Okay. Yes. Okay. So in
Yeah,
that case,
yeah.
The utility is 6. So which is
Yes,
correct?
6.
6 or 4?
And game terminates. So it is utility is 6, I think.
Okay. So you see in war of attrition, specifically for this game, whenever a player leaves, the other player wins. So in that case, it doesn't matter how long he stays after that round. He will win, and the utility will be 8 minus 2 is 6, not 8 minus 4. For this game, It specifies if the other player leave, then the other player wins. If a player leaves, the other player wins. So since the first player or the player B is leaving in round 1, player 1 is actually winning in round 1. So this is the utility he is gaining. Is this correct? So 6 is the correct answer.
Got it. Right.
You can check, there can be multiple versions of this war of attrition. You have to see the what description is given in the problem. All right. So this is not important if this descriptions will let you know how to analyze a game. All right. So I'm not saying this is the correct definition of war of attrition. There can be multiple definitions of a game. You can just tweak and make the game very different from what it was earlier. The thing which to take from here is how to derive the utility of a player. That is more important than these technicalities. I may be wrong, so this definition may be wrong. That is not what the essence of this question is. The essence is how will you derive the utility of the player. All right.
So I have one doubt here. You're saying player B stays only for one round, so it automatically means that player A has to stay for 2 rounds to win the competition, right?
Okay, stays for one round. Okay. Just let me check. Player B stays for one round. Yes. It is not player one. B is leaving in first round. Stays for one round. Player B stays for one round. So it is leaving in second round. Yes. It will be 8 minus 4. This will be the answer. If it is stated that player B is leaving in first round, then this will be the answer. All right. So yeah, that is what I was saying. How to derive the utility is more important. All right. So I was wrong. Thank you for correcting me. So when it says player B is leaving in first round, then this will be the correct answer. When it is saying player B is staying for one round, it means that player B is leaving in the second round, then this will be the answer. All right.
And one more doubt: if player B is leaving in first round, what will be the payoff for him? Will it be -2 or
Minus. So when he is leaving for in the first round, then it will be -2, and when it is leaving in second round, it will be -4. Sorry, -4.
then leaving in first round seems to be the same as staying in first round, because even staying in first round is -2.
Okay, so you see, we are not talking about the best response of player 2 or the Nash equilibrium of this game. We are just talking about what will be the utility of this scenario, this player 1 for this scenario. When you talk about what is the best response of player B, I will say that the best response of player B is to just leave at 0 round, don't play at all.
Okay.
And in fact, the Nash equilibrium of this game will be 0, 0. We'll see those things. We'll see those things. Will it be 0, 0? I'll have to check. But yeah, the question is not what is the best response of player B.
Okay.
Any more doubt? All right. So I'll just wrap up. So initially I couldn't just give my introduction clearly. I was in some other thought. So I'll just let you know who am I. So I am Shubham Keshri. I am working in the Department of Management Sciences at IIT Kanpur. My area of work is actually operations research, and game theory is a subject taught in operations research. I'm not actually working in game theory. I'm working in a separate area called integer programming. But yeah, I know well game theory. I might make some errors here and there. So please just interrupt me and correct me. All right. Anything else?
No, thank you. You have been really great and it was a very worthwhile class. Thanks a ton. Thank you.
So just check the questions. If you have doubt, we can discuss in the next coming class, next Friday.
Okay. Thank you.
Thank you. Thank you for joining.
Thank you, sir. Thank you.
I'll just end the class now.